The National Center for Education Statistics monitors many aspects of elementary and secondary education nationwide. Their 1996 numbers are often used as a baseline to assess changes. In 1996, 34% of students had not been absent from school even once during the previous month. In the 2000 survey, responses from 8,302 students show that this figure had slipped to 33%. Officials would, of course, be concerned if student attendance were declining. So these figures give evidence of a change in student attendance. So 1% may or may not be significant. You can't just decide that it's 1%. Okay, so we're going to go through and do a hypothesis test to figure out how often, again, the whole point of the hypothesis test is to get a p-value, a probability. So figuring out how often we would get survey results of about 33%. Okay, and we'll make a conclusion from there. So what's the first step to our hypothesis test? You got to do the hypotheses. So what is our null hypothesis going to be?
0.34.
P equals 0.34. It is very important that you have all of those things I just wrote. The null hypothesis, you can't write the null hypothesis is 0.34. That's not anything. Your null hypothesis is that the population proportion is 0.34. There has been no change. Okay? You should also be able to just say what that is in words. If you don't know what I'm talking about and you can't describe to me what I'm talking about in words, then you're going to miss multiple choice questions. Okay? What's the alternative hypothesis then? It says that we'd be concerned if student attendance were declining, so we're going to check less than. I could also see where you could interpret this question. It says, do these figures give evidence of a change in student attendance? So that can be interpreted as not equal to. So I'm going to go ahead and do it as less than. But I also am going to go back and show you what you do if it was not equal to, because we haven't done that yet. Okay? That's the hypotheses. You should have those. It's a requirement. It's not optional. Again, you need to have all of those symbols as well. Those are not optional. Notice again, it's not p hat, it's p. We're using 0.34 for both of them, right? All in the details here. All right. What's the second step? Conditions. So we have quite a few things we need to say. First, we need to talk about independence. So what are we worried about being independent? Right. So we have to assume that the 8,302 students are independent of one another. We're assuming that, so we back that up with two conditions. So what's the first condition we back up the independence assumption with? Yeah, we can do that one. So 10%, 8,302 is less than 10% of all students, since it says it's a national study, right? So that's one of the conditions. What's the other? Okay. Does it anywhere in this question say that this is a random sample? No. So don't say it's a random sample. So what are we going to say instead? The 8,302 students should be a good representation of all students' attendance. Okay. After the independence assumption, we have the sample size assumption. How do we show that our sample size is large enough? Our success failure condition, right? We want 10 successes and 10 failures at least. So we have n times p and n times q You actually have to show the numbers and show that you worked it out. Notice I'm using 0.34. And you would actually find, you'd calculate both of those. But both of them are going to be greater than 10. Questions about the condition? So now we know how to do a confidence interval and a hypothesis test. So you have to be clear about what you're trying to do. So part of the condition step is to write a sentence. It is not optional. You need to clarify what you're doing. So because the conditions have been met or have been satisfied, or however you want to write that. Now what you're really saying is I can use a normal model for the sampling distribution of student attendance. Right? That's the whole point that you check the conditions. You're making sure you can use a model. We are making sure we can use the normal model. Once you check the conditions and you know you can use the model, you want to state what you're doing. So I will perform a one proportion z-test. Questions about that? So step 1 was the hypothesis, step 2 is the conditions. That includes that sentence, or 2. Any questions? So then what's the third step? Right, the math. You don't have to title the sections. I'm going to here, but so mechanics or the math, we're actually showing the work. Again, the whole entire point of a hypothesis test is we're trying to find a probability so we can make some sort of decision. So, if you recall, if I can find it, it's on one of these slides up here somewhere. Yeah. We find a z statistic, and we take our sample proportion, we subtract our population proportion, and divide by the standard deviation. So, for this, for z, what is our sample proportion? Sample proportion. 0.33. Right, 33% is what we got in the 2000 sample. That's what we sampled. That was our new sample. 0.34 is our population proportion, what we believe to be true. And then we divide by the standard deviation, again, of whatever we think about going on in the population. So I have 0.34, 0.66, 8,302. Please note that I have only used the sample proportion in one place in this entire problem so far. I did not use the 0.33 in the hypotheses. I did not use the 0.33 in the conditions. I did not use the 0.33 in the standard deviation part in the denominator. You should only be using that sample proportion when you find a z, not one place. Everything else should be based on what you think is happening in the population. You're doing that entire test assuming the null hypothesis is true. You're doing the entire test assuming there has been no change. Only your probability at the end can show there's been any change. All right, so you go through the whole test assuming there has been no change. All right, so then we actually have to do the calculation here. So .34 times 0.66 divided by 8,302 square root of that. And that would be 0.33 minus 0.34 is negative 0.01 divided by that answer. And I get a z statistic of negative 1.92. All right, so remember, your z statistic is a z-score. That means you're using a standard normal model with a mean of 0 and a standard deviation of 1. And we're going to use it to find a probability of getting these survey results. You need to get in the habit then of drawing the model really quickly. It's a part of the mechanics. We have a mean of 0 and a standard deviation of 1. We got a z statistic of negative 1.92. All right. Now we need to decide what probability do we want. So go look at your hypotheses. We think that the attendance has been declining. Right? We think that p is now less than 0.34. So because of that, we want what's happening below negative 1.92. Yeah? So how do I find that probability? Normal CDF. So normal CDF, we go from negative infinity to negative 1.92, and we'll leave the mean and standard deviation alone. We've got a z-score, so everything is standardized, so we don't have to change anything. And so our p-value, 0.0274. Now, what does that mean? That means 2.7% of the time I would get survey results similar to these that I got. So similar to the 33% of 8,302 that hadn't missed school in a month. Assuming the null hypothesis was true. That's what we did the entire time. That's what a p-value is. It's telling you what percent of the time you're going to get survey results like you got. All right, so I gave you a threshold last week for what was a high p-value, what was a low p-value, right? So what was that threshold? 0.05. So is my p-value high or low? It's low. It's below 0.05, so it's low. And so we need to make a conclusion. So we've done the first 3 steps. We have hypotheses, we have conditions, we've done the mechanics. I've got a p-value. I know what that p-value means. And so now I need to make some decision and make some conclusion. All right, so here's my conclusion. Step 4. With a low p-value, again, p-value is a fancy name for probability, of 0.0274, we reject the null hypothesis. It seems there is evidence that school attendance is declining. In your conclusion, you have to have 3 things every single time. 1, you have to have a p-value. You need to report it in your sentence. 2, you have to have a decision. Do you reject or fail to reject? And it needs to be based on the p-value, not just written down like I reject. That's why I said with a low p-value of. See, I set that up. And then 3, it has to be in context. hence the second sentence. And then the whole entire second sentence is the context part. So I wrote my conclusion with a p-value and if I rejected or failed to reject. And I just went back and said what that meant. That's the context part. We rejected the null hypothesis, so that means we think that the alternative is true. So we think the proportion of students that are not absent from school is less than 0.34, right? So we think that school attendance is on the decline. Okay, there we go. All right, now, that's all the steps. That's every single hypothesis test should have all of those things. There is one more thing you could do. If it asks you to, you could. You don't have to. If you wanted to see how much school attendance was declining, you could do a confidence interval. All right, so you could go back and use the 0.33 and do a confidence interval here at the end. We already checked the conditions, right? So I could do a confidence interval and come up with some statement. I'm 95% confident that school attendance is actually between this percent and this percent. So we know how much the size of the effect is. Like how much is it declining? That's not required. It's going to be required on one of your homework questions tonight. Because you need to be thinking about those things still. Chapter 19 is not going away. Now, I did say we haven't done one where we have P is not equal to. Right? We haven't done that yet. So let's say we interpreted this as give evidence of a change. And we wrote that as P is not equal to 0.34. Okay? So everything is the same. All of the conditions are the same. The statement's the same. The mechanics are almost the same. You still do this z-score part. Okay? However, if I say not equal to, I'm not just worried about this lower tail. I'm also worried about the upper tail. Because change could be increase or decrease. So you have negative 1.2, but you would also use positive 1.2. You'd use the z-score that's symmetric on the other side. Okay? So because of that, once I get my p-value is for one side. That's fine. But then I multiply that p-value by 2 to get two sides. All right? Because this green section is the same as the red section. All right, so you do everything the same, but you multiply your p-value by 2. Then you'd have a new p-value. In this case, it would be right over 0.05, so it would actually be high, and we would fail to reject. So there is not much evidence there's been a change. It's right above 0.05, so it's kind of on the line. So that's why I said use my threshold of 0.05 for now, but in Chapter 21, we'll talk about some more official type thresholds. But does that make sense for not equal to? Okay. Any questions? Do you think you have enough information to try this on your own? All right, so this is your homework assignment. Number 10 is just looking at a hypothesis test that's already been done and pointing out all the errors that have been made. 17 and 20 are hypothesis tests that you're going to do on your own. 28 is also a hypothesis test that asks you to do a confidence interval at the end to show how large of an effect there's been.